Sanibonani. Sibusiso Miyeza, ngizoba mude namhlanje. Ngizosuka ngihlala udabeni. Khona nje isehlakalo esesenzekile. Pertaining this meeting noma this video engizoyenza njengamanje. Kodwa ngizochazela at the end of the video. Now let's get into the video. Okay. So nali iphepha sizoqala sithi ukuba busy ngalo, sizokhuluma ngama-reaction rate. Selibona iphepha Physical Science Chemistry paper 2 November 2018. This is physics, then we'll be doing the reaction rates questions. Sizofocusa nje based kuma-reaction rates questions. Then sothi uma sesiqedile ngamaphepha from 2018 to 2021. Then mase siqedile ngama-reaction rates from those papers, then we do other parts or move to chemical equilibrium kuwo futhi lawo maphepha, but sizwancenga kancane. Okay, so let's look for a question ethi mayikhulume ngama-reaction rates here. Njengamanje na i-question la siyayibona ethi mayikhulume ngama-reaction rate. So it is 1.4. Ithi activation energy can be best described as the minimum energy required to. Uma ngabe sikhuluma nge-activation energy, uma sikhuluma nge-activation energy, sishilo activation energy, it is the minimum energy that is required for the what? For the reaction to does what? To take place. So i-energy siyidingayo ukuthi i-reaction yenzeke, that is activation energy. And ukuze kwenzeke i-reaction, there must be an interaction of what? Of atoms, or there must be an interaction of molecule. Yabona kuzomela kube khona ukushayisana noma ukungqubuzana kwama-molecule ukuze kuzokwenzeka i-reaction. So this is the minimum energy that is required for the reaction to does what? To take place. So uma ngabe sikhuluma ngokungqubuzana noma interactor kwama-molecule noma kwama-atoms, sizobheka ukuthi there must be collisions, because when you interact or uma ngabe singqubuzana siyacollidana. So which means i-answer sizoyibheka la from A to D, sizobheka i-answer kuba collide phakathi. Uyabona lento le? So the first answer ithi cause effective collisions, non-collisions, it make or number B, but make reactants molecule collide, non-collide. C, but change the orientation to reactants molecules. D, but increase the kinetic energy of reactants molecules. So uma uthi uyabheka la kula ma-option esanikezwe, u-A no B ama-mention something that is about collision. Uyabona le nto le? So which means u-C no D, they are already excluded. Asizukhuluma ngo-C no D. Then sesizokwazi ngane ukuthi yona kuyiphi e-right between A and B. Into esizokwazi ukuthi yona kuyiphi between A and B, it is because uma ngabe phela njengamanje sinjani, uma ngabe njengamanje noma uma ngabe when there are interactions of protons, or not of protons, of atoms, when there are interaction of atoms or molecules, that means the reaction is taking place. And ukuze i-reaction yenzeke, there must be effective collisions, not just any collisions or interactions. There must be effective collisions, because this is the minimum energy that is required for the reaction to take place. Ukuze i-reaction yenzeke, there must be interactions, but ama-interaction hayi noma imaphi, there must be just effective collisions or effective interactions. So already the answer is between A and B, because basho lapho ku-A bathi yena cause effective collisions. So since land no effective collisions, siyazi ukuthi ukuze kube khona effective collision, it is whereby the reaction is taking place, or it is whereby i-reaction kumele yenzeke, so that there must be effective collisions. Uyabona le nto leyo? Okay, now let's look for another questions it's maybe related to the reaction rates. I guess one understand it, because the activation energy on my last video ngikhulumile nge-activation energy ukuthi iyini activation energy. Ngize ngayiveza kuleya graph ka-exothermic and endothermic ukuthi iyona kuyiphi activating energy. So if uthi ubungazi uyibona ngicela ukuthi ubuye ubuyele back uhambe uyibuke lo video, then mase uyabuya uzobona lento engikhuluma ngayo la. Ithi 1.5, which statement is correct for a system in dynamic equilibrium? No. This is not direction rate anymore. isiya movalent isiya ku-chemical equilibrium. But i-dynamic equilibrium, it is the rate whereby i-forward reaction iyalingana nani ne-rate of the reverse reaction. Sizokubona lokho uma ngabe sisithinta yini ama-questions that are based on chemical equilibrium. 1.6 chemical equilibrium, 1.7 KC chemical equilibrium. Seems like awasekho ama-question athinta i-reaction rates from the multiple choice questions. This is organic chemistry, and then this is organic chemistry, then organic chemistry. Na question yama reaction rates, question 5. So bathi the reaction of zinc and excess dilute hydrochloric acid. Uzinc uyini? Uzinc uyi-solid and hydrochloric acid uyini? Uyi-aqueous. So already uma ngabe sengithinta i-solid sengithinta i-aqueous, khona ama-factor sengiwathintayo kunama-factor enginawo awu-5 engikhulume ngawo on my last video. Ngithe ama-factors nawo awu-5. Number 1, it is surface area of solids. Number 2, concentration of solutions. Why ngithi concentration of solution? Because lo muntu loyo u-affecta ini i-aqueous kuphela. Then number 3, there must be pressure of gases. Pressure of gases, why ngithi it is the pressure of gases? It is because i-pressure lizo affecta i-gas kuphela. So ukuze u-affecte i-gas you must be, or rather ukuze u-affecte i-pressure you must be a gas. Then number 4, that is addition of a catalyst. Addition of a catalyst i-affecta wonke ama-states. Ayinendaba ukuthi uyi-solid, ayinendaba ukuthi uyi-gas, ayinendaba futhi ukuthi uyi-aqueous. Then the last factor, kulama factor of 5, it's temperature. Temperature, it affects them all. Ayikhethi temperature na iyafana ne-catalyst. Athi ngikhombise lama factors engikhuluma ngawo la. Factors I'm talking about here. Now lama factors engikhuluma ngawo. So number 1, surface area of solids. Why is it surface area of solids? Specifically, it is because surface area is affected umuntu oyi-solid kuphela. It is whereby usuzothola ukuthi sishintsha i-surface area from being solidified to being powder. Uyabona ukuthi mhlawumbe nje sinama-granules sawagaya kwafomeka ama-lumps, sawagaya ama-lumps then also kwafomeka u-powder. Then concentration of solution. Concentration of solution is specifically based kumuntu oyini, kumuntu oyi-aqueous. Hayi wonke umuntu but umuntu oyi-aqueous. Pressure of gases, i-pressure izo-affect umuntu onjani? Umuntu oyi-gas kuphela, because iyasho ukuthi this is the pressure of gases, not pressure of solids and not pressure of aqueous. Addition of a catalyst. Catalyst affect all states, all states, which means we gas, we solid, we aqueous, affect catalyst and also temperature. These are the 5 factors. These are the 5 factors that affect the rate of the what? Of the reaction. 5 factors. Meluwazi mpethu, meluwazi futhi ama-function akhona under these factors. Meluwazi. Because uma sebethi chaza using collision theory uzobe uchaza based on these 5 factors. Let's go back to our question paper. So, bathi the balance equation for the reaction is now zinc bamhlanganise no hydrochloric acid kwakhipha zinc chloride plus hydrogen. So zinc wami is a solid, already surface area siyathinteka because surface area focus kuma solids. Then hydrochloric acid is an aqueous, already concentration siyathinteka because concentration ifocus kubantu abama aqueous. Already zinc chloride is a what? Is an aqueous, so effect ethinteka kuzoba concentration because i-concentration ifocus kuma aqueous. Then uhydrogen uyini, uyi-gas, and also the factor that is involved here kuzoba i-pressure because i-pressure ifocus kumani, kuma gas. So the reaction conditions used and the results obtained for each experiment are summarized in the table below, which means sinama conditions noma ama-readings ebekade enziwa per each experiment ukuthi mhlawumbe i-concentration sense i-concentration engaka sense i-mass engaka kwi-temperature engaka kuthatha isikhathi esingaka ukuthi i-reaction yenzeke bona. Iyo into abazosinikeza yona in this table. So the same mass uma ngabe bekhuluma nge-same mass basho ukuthi abasho ukuthi there was no change in mass, kodwa into abakutshela yona basho ukuthi the amount of mass was the same. Kungenza ukuthi i-mass esiyisebenzisile kuwonke ama-experiment ibe-2 gram, kodwa phela kwenye experiment utholuthi ade sizosebenzisa i-powder, kwesinye isikhathi ade sizosebenzisa ingama-granules, kwenye experiment bese sisebenzisa i-ama-lumps, yabona? I-mass iyodwa kodwa kuwukuthi sisebenzisa ngendlela engafani per each experiment. Sizobona nala kulama readings ukuthi bayisebenzise kanjani. Kuthiwa the zinc is completely covered in all experiments. Mabethi it is completely covered. Mabethi zinc is completely covered, basho ukuthi uzinc ureacte waphelela, akekho uzinc osalile. Kusitshela ukuthini lokho mangabe umuntu ereacte waphelela? Umuntu phela mangabe ezo-reactor aphelele, that means that person is the limiting reagent. Yes, lo muntu mangabe ezo-reactor aphelele kusho ukuthi lo muntu uyena esidetermine ngaye ukuthi izokhipha i-product engakanani, yabona? So uma ngabe let's make an example, ufuna ukubeka le nto limiting reagent. Let's make an example. Let's go back to our board. Let's make an example. Nginabantu ababili la. Lona uyi-limiting reagent. Uma ngabe lo eyi-limiting reagent, lona kusho ukuthi uyena ozodetermine ukuthi ngizokhipha i-product engakanani, yabona? Okusho ukuthi uma ngabe ngino 5 gram wani ka-flour, ngizofaka u-F. Lona eno 10 gram of flour, F. Then labantu laba bekhiphe amagwinya, ngizofaka SG amagwinya la. So uyabona ukuze mina ngazi ukuthi ngizokhipha amagwinya angakanani, kuzomela ngibheke umuntu oyi-limiting reagent yami, which means i-product yamagwinya engizowakhipha incike ekuthenini ngino flour ongakanani, yabona lento leyo? So i-product no ayincikile ekuthenini no flour ongakanani, ya incike ekuthenini no flour ongakanani, yabona? So i-product yamagwinya engizowakhipha incike ekuthenini no flour ongakanani. So lo flour lo once waphela kusho ukuthi ngeke ngisawakhipha ama-product, yabona? All in all into engizama ukuyisho ukuthi the limiting reagent umsebenzi wayo ukuthi izodetermine ukuthi sizokhipha i-product engakanani in a reaction. Then let's go back to the question paper. So zinc is our limiting reagent. Zinc uyena ozodetermine ukuthi sizokhipha uzinc chloride ongakanani noma sizokhipha uhydrogen gas ongakanani, because uyena i-limiting reagent. Now ama experiments, they are summarized in the table below. Experiment 1, the concentration of hydrochloric acid was 2 mole per decimeter cube. The volume of hydrochloric acid was 200 centimeter cube. The state of division was powder of zinc. The state of division of zinc was powder. The state of division siyafana ne-surface area. Kusho ukuthi uzinc initially noma uzinc experiment 1 bekade powder. Then the temperature was 25 degrees C. Then i-reaction time. Uma besikhuluma nge-reaction time sikhuluma ngokuthi isikhathi esithathwe i-reaction ukuthi yenzeke. Kusho ukuthi i-reaction ithatha isikhathi esingango-7 minutes ukuthi yenzeke on experiment 1. Then now we move to experiment 2. Experiment 2 uyabona ukuthi the concentration kontenzekile nge-concentration as ngimove from 1 to 2. I-concentration was decreased from 2 to 1.5. Uyabona le nto le? And the volume of hydrochloric acid on experiment 2 is the same as on experiment 1. The state of division now of zinc experiment 2 sesingama-granules, which means njengamanje sengi-decreasile i-surface area. Why ngithi mina ngiyayi-decrease surface area as I'm moving from powder to granules? This is the reason. This is the reason. Let's say in a bucket lang. This is bucket 1. Bucket 1. This is bucket 2. They have the same length. All these buckets, they have the same length, these buckets. So this is bucket 1, this is bucket 2, this is bucket 3. So I guess it like initially in granules. nginama-granules la initially. Uma ngabe ngiwagaya ama-granules, esithi mhlawumbe igranule elilodwa uma ngabe ngiligaya, ngizokhipha ama-lumps awu-2. Ngizokhipha ama-lumps awu-2 noma awu-3 rather. Ngikhipha ama-lumps awu-3, 3. Uma ngabe ngiwagaya ama-lumps, ngizokhipha ini? Upowder. Powder. Uma ngigaya ama-lumps awu-3 ngizokhipha upowder ongaka. Uma ngigaya futhi lama-lumps awu-3 mhlawumbe ngizokhipha upowder ongaka. Upowder ongaka. Khona amanzi njalo kula mabhakede. Ngizokhipha upowder ongaka. Inawo kulo munye iphathi ukuchitha ngaphandle kodwa asikisidingo naka nje lapha edeni. So these are the granules ngizowalebula G. These are the lumps ngizowalebula as L. This is powder ngizoyilebula as P. Na into enzakalayo ke mfowethu. Ngicela ubuke uma ngabe ngiswala kuma-granules or otsho ngikhulumisa kuqala ngama-granules. Uma ubuka ama-granules lapha ebhakedeni elinamanzi, ama-granules a-occupy ispace esincane. Uyabona ukuthi ama-granules asendaweni nje encane awagcwele kakhulu ebhakedeni, uyabona? But ama-granules sengiwagaya ngiza kuma-lumps. Uyabona ukuthi ama-lumps nje manje ase-occupy indawo ethi mayithi ukuvuleka ebhakedeni. Ama-lumps ase-occupy indawo ethi mayithi ukuba ningana ebhakedeni, uyabona? Compared to ama-granules. Uma bese ngimuva from lumps to powder, uma ngisuka ngiza ku-powder, upowder mawuthi uyayibheka ebhakedeni usuyagcwala manje upowder, yabo usu-occupy the bigger amount of volume one webhakede, which means lento isho ukuthini? Ithi lento as I'm moving from granules to powder, the surface area is increasing. Because as I'm moving from granule to powder, baqala ba-occupy ispace esiningi sebhakede, which means lo muntu o-occupy ispace esiningi sebhakede has a larger surface area, or it's occupied a larger surface area. And as you occupy a larger surface area, kusho ukuthi maningi ama-particle which are exposed ukuthi kwenzeke i-reaction. So as ama-particle emaningi are-exposed for the reaction to take place, that means the reaction rate la ku-powder is what? Is higher. Is higher. The reaction rate is higher. Kuyi-inversing. Kusho ukuthi uma ngabe i-reaction i-higher as ispace esiningi si-occupied, kusho ukuthi i-reaction izoba low as ispace esincane si-occupied, which means the reaction rate lapha kuma-granules izoba njani? Izoba low. Now let's go back to the question. Okay, njengamanje uyabona laphana ukuthi ku-experiment 2 senginama-granules, which means my surface area was decreased because ngisukile kumuntu o-occupy space esiningi obekade ewupowder, ngaka umuntu o-occupy space esincane oyini ongama-granules. But now let's move to temperature. I-temperature of hydrochloric acid is the same. Now look at the reaction time mfowethu. Ngicela ubuke i-reaction time. Ngithe mina umuntu uma ngabe exposed noma umuntu uma ngabe evulelekile when particle they are more exposed ukuthi kwenzeke ini i-reaction. Uyabona ukuthi kuzothatha isikhathi esincane ukuthi enzeke, which means the reaction will take just a small amount of time ukuthi yenzeke. Uyabona lento leyo? Lo muntu lo exposed i-reaction yakhe ithatha isikhathi esincane ukuthi yenzeke, but lo muntu lo solidified i-reaction yakhe izothatha isikhathi esinjani esithi masibambeke ukuthi senze njani ukuthi yenzeke. Ngizokwenzela example. So ake sithi ngizothatha uchoki. Ngizothatha uchoki nje into ethi mayibe lula nje. Ngizothatha uchoki ngufake emanzini, uchoki oyi-solid. Nguthathe ngufake emanzini. Lo choki owu-solid uma ngabe ngufake emanzini, bese ngithatha yonke lo combination leyo ngibeke emlilweni. Ngifake emanzini njalo sebhodweni ngibeke emlilweni. Lo choki lo uzothatha isikhathi ukuthi uncibikala. Uthatha isikhathi lo choki ukuthi uncibikala because uyini? Uyi-solid. But uma ngabe ngizothatha just upowder ngufake emanzini bese ngufaka emlilweni, uzobona upowder ugcwala yonke indawo. Uyabona ukuthi i-reaction izoshesha ukuthi ihlangane. Uyabona i-reaction izoshesha ukuthi ihlangane. Uzoshesha ukuyibona le combination kachoki namanzi. But lo choki lo kade uyi-solid uzothatha isikhathi ukuthi ugcwale kuwo wonke lamanzi because azoncibikala kancane kancane. But lo powder uzovela usabalale kube just a combination or just a solution. Into engifuna ukuyisho la ukuthi as umuntu engama-granules uzothatha isikhathi eside ukuthi enzeke, but umuntu owupowder uzothatha isikhathi esincane ukuthi enzeke. Yabona? So umuntu ovalelekile uthatha isikhathi esincane, or umuntu ovalelekile uthatha isikhathi esiningi ukuthi enziwe, but umuntu ovulelekile uthatha isikhathi esincane ukuthi enziwe. Uyayibona nawe mfethu, uma ngabe uvalile uthatha isikhathi esiningi ukuthi wenziwe. Uyabona? Because kusamele uvule ukuze uzokwenziwa. But uma ngabe uvulelekile uthatha isikhathi esincane ukuthi wenziwe because asikho isidingo sokuthi ngiqale nguvule uvele wenziwe. Uyabona lento leyo? Yeah, ngikhuluma kodwa ngopowder la nama-granules. Okay, now let's move to experiment 3. Mabu experiment 3 compared to experiment 2, the concentration was increased. Yes, the concentration was increased from 1.5 to 5. But the volume of hydrochloric acid, it's remained the same. Mabu 2 no 3. But to move, we have a state of division of zinc. The surface area now of zinc is increased because now I'm moving from granules to powder. As I'm moving from granules to powder, I'm increasing the surface area because now more space or more volume of the container will be occupied. Then near with temperature of hydrochloric acid njalo ngizobuka experiment 3, it remains the same as I'm moving from 1 to 3 or as I'm moving from 2 to 3. Then the reaction time ka experiment 3 is 5. And why reaction time ka experiment 3 ibencane? It's because phela reaction 3 powder, which means uvulelekile uzothatha isikhathi esincane ukuthi enziwe. Uyabona lento le? But experiment 2 uyena oyinkinga because manje uvalelekile noma uvalile, so yena ngoba evalile uzothatha isikhathi esiningi ukuthi enziwe because kusamele ukuthi bemvule kuqala, kusamele bewaqhaqe kuqala ama-particle before ukuthi kube khona i-interaction ezokwenzeka freely. Uyabona lento le? Okay, then now let's move to experiment 4. Experiment 4, buka i-concentration of hydrochloric acid, it was decreased from 3 to 4. Ibikade u5 on experiment 3, now isiyamova isiba 1.5 on experiment 4. Let's look at the volume of hydrochloric acid. It was 200 on experiment 3, now it is 400 on experiment 4. If volume for it, it is not a factor. But volume pressure, because pressure it is inversely proportional to volume, which means as I'm increasing in volume, the pressure will decrease. But as I'm decreasing in volume, the pressure will increase. That is just the proportionality. On the last video. Okay, to check this proportionality in Kurmanga. Yeah. Okay. Nansi le proportionality ngikhuluma ngayo. Uyabona ngishilo ngathi la pressure is inversely proportional to volume, which means as I'm increasing volume, as I'm increasing my pressure, my volume does what? Will decrease. Or as I'm increasing now the volume, my pressure does what? Will decrease. As now I'm increasing the volume, my pressure does what? Will decrease. So this is the proportionality between the volume and the pressure. They are inversely proportional, which means as I'm giving the volume, volume, pressure. Mama volume volume be increasing, which would pressure is decreasing. Just data clearly. Let's go back to the question. Then now let's look at the reaction time of experiment 4, or before the reaction time, volume, state of division. The state of division of experiment 4, back to our granules, which means we are decreasing the surface area. We are born but the temperature is the same. The reaction time of experiment 4 we are not given. But X, what is the value of X? But ngizobuya ngizokukhombisa ukuthi ithola kanjani le value ka X. Then now we are on experiment 5. Experiment 5, mawubuka concentration of hydrochloric acid, it is 2, and it has increased compared to experiment 4 because it has moved from 1.5 to 2. The volume of hydrochloric acid, it has back to 2, yabona isisuwile kulo 4. 400 is well back to 200. Then the state of division of zinc, it is now back to powder. It's well back to powder. But we say increase of the surface area. Now the temperature, man. The temperature we are born siswa from 1 to 4 below Q25. Experiment 5 is 35, which means they have increased the temperature. And umangabu increase the temperature, uzongitshela ukuthi my reaction must happens faster. No reaction yenzeke. Because when we increase the reaction, more particle will have sufficient kinetic energy. It means more particle will be exposed ukuthi kwenze njani ukwenzeke ini i-reaction. Uyabona le nto leyo? So uma ngabe nje increase i-temperature, increase i-temperature ne-reaction yami izokwenzeka faster. Le nto ngizoyenza, for example, asibule lapha. For example, ngizokwenza nje just a quick example ngale nto increase kwe-temperature. So let's say nginesitofu la, isitofu sami lesi, isitofu sami ngibeke ibhodi la phezulu esitofini sami, then isitofu sami ngasibeka saba ku-2, then naso esinye isitofu sami esila, ngibeke ibhodi la phezulu, lesi ngizosibeka ku-6. Ngicela ubukeke la, kwaba khona amanzi la phakathi, water, ngizofaka nje just W representing water, kwaba khona amanzi la, ngizofaka just W. So ngicela ubuke la ukuthi i-reaction kulo muntu onestove esiku-2 izokwenzeka slow. Why? It's because i-temperature laphana noma i-temperature around that condition is very low compared to 6. Uyabona? Because uma ngabe ngisitofu ngisivulile ngasibeka ku-6, which means there will be more heat. I'm increasing temperature and the reaction will happen faster. And ngiqonda ukuthi manje the reaction will happen faster, it is because lamanzi lawe ngiwabeka isitofu esiku-6 azoboila kuqala kunamanzi engiwabeka isitofu esiku-2. So when you increase temperature, you are increasing the rate of the reaction. Masikhuluma nge-rate sikhuluma ngokuthi how fast is the reaction taking place. So you are increasing ukuthi reaction mayenzeke faster. So let's go back to the question. So now we are on experiment 5, then sikhulumile nge-temperature, then ngicela ubuke i-reaction time yakhona. Iziyazi isho nge-reaction time ukuthi ithathe 4 ukuthi yenzeke, ithathe u4 minutes. And the reason ithathe 4 minutes, it is because phela bese sinyuse isitofu la from 2 sasisa ku-6, therefore amanzi asheshe aboila in 4 minutes rather than la isitofu ade siwu-2 khona lapha ku-experiment 2 nje sithi isitofu ade siwu-2 khona. Uyabona ukuthi amanzi abhole after 14 minutes, which means uma ngabe i-temperature incane amanzi azophuza ukuthi abhole, so the reaction is low. But uma ngabe i-temperature i-high, isitofu siku-6, the reaction will be fast, amanzi azoshesha ukuthi abhole. Now let's go back to the questions again now. 5.1, but experiment 1 and 5 are compared. To write down the independent variable. Now the independent variable between experiment 1 and experiment 5. So uma ngabe sikhuluma nge-independent variable, the independent variable will always be a factor. Independent variable will always be a factor because i-reaction rate idependele kwi-change esiyenze kwi-factor. Remember, the purpose of these 5 factors ukuthi awazositshengisa i-reaction rate, and asitshengisa kanjani i-reaction rate, there must be a change eyenziwa kuleyo factor. Let me make an example here. Uma ngabe ku-experiment 1 kade ngisebenzise i-temperature ewu-25, ku-experiment 2 ngasebenzisa i-temperature ewu-2540, ikhona yini change engiyenze kwi-temperature? No, there's no change engiyenze kwi-temperature. It is 25, which means angikwazi ukuthi ngikhulume nge-temperature kulama factor azo-affecta i-reaction rate in this case because there was no change that was done on temperature. So ukuze kube khona i-effect eyenziwa i-factor kwi-reaction rate, kuzomele kube khona i-change eyenziwa to that factor. Uyabona? Njengoba ngicela sibuke u5 no1 ukuze ngicacisele into engishoyo. Uma ubuke u5 no1, i-concentration of hydrochloric yabo iyafana, of hydrochloric acid iyafana. But uma ubuke i-volume yabo iyafana still. Uma ubuke i-state of division siyafana still. But uma uzobuka i-temperature yethu, i-temperature yabo ayifani. U-experiment 1 isitofu sakhe siku-2, but u-experiment 5 isitofu sakhe siku-6. U-experiment 1 akashisi kuno-experiment 5, which means u-experiment 5 uyashisa ngoba isitofu sakhe siku-6 phela. Uyashisa u-experiment 5 kuno-experiment 1, uyabona? So u-experiment 5 uma ngabe eshisa kuno-experiment 1, that means the reaction is faster at experiment 5 rather than on experiment 1. Uyabona? Yeah. So all in all, labafuna the independent variable. The independent variable will be a factor. Yipi factor. Le factor wenziwe i-change kuyona. So uma ubuka concentration, there was no change yenziwe concentration. Uma ubuka volume, there was no change yenziwe volume. Uma ubuka state of division noma surface area, there was no change yenziwe surface area ku1 na ku5. But more temperature, there was a change in temperature, which means our independent variable in this case will be temperature. But noma bengasayibuzanga ngale, the dependent variable will always be reaction rate. The dependent variable will always be reaction rate because i-reaction rate idependele ekuthenini siyenzeni i-factor. So now define reaction rate. Reaction rate, that is the change in concentration of reactants or products per unit time. To write down the value of X in experiment 4. In terms of chaza le. And iwu-2 marks, iwu-2 marks le mpahla le. Yeah, value of X, iwu-2 marks. Which means bayazi ukuthi bayibuza ngwana kwenze njani. Ngicela ubukeke u-X ku-experiment 4. Ukuze uzo-identifya i-value ka-X in experiment 4, khona into okumele uyenze kuqala. Ngicela ubuke u-experiment 4, mese ubuka u-experiment 4 ukuthi ayikho yini enye experiment u-experiment 4 athi makacishe afane nayo. Yabona? Noma awekho nama-reading wenye experiment athi mawacishe afane nama-reading aku-experiment 4. Because njengamanje ukuze sithole le value of X kuzomele sikhulume ngevalue ka-X but with respect to the other experiments, because phela u-experiment 4 asenzanga nedwa, senze namanye ama-experiment. So kuzomele sibuke ukuthi kwamanye ama-experiment okay bengithola isikhathi esingakanani ngoba nje sengizothola lesi sikhathi lesi esila ku-experiment 4 which is the value of X. Ngicela ubuke u-experiment 2 no-experiment 4, angizokubukisa amanye ama-experiment, ngizokubukisa direct nje u-2 no-4. Uma ubuka u-2 no-4 i-concentration of hydrochloric is the same. Uma ubuka u-2 no-4 the volume is different of hydrochloric acid, but ukuba different kwe-volume ka-hydrochloric acid akunawo umthelela kunama-readings esinawo, because u-hydrochloric acid uyini uyi-aqueous. So uma ngabe kune-difference yani ye-volume, i-volume iqashise i-pressure, i-pressure iyayithinta i-aqueous. Sengibuza i-pressure ayikaze yayithinta iyakwazi. So i-pressure since ingayithinta iyakwazi kusho ukuthi indaba yale column le ye-volume mangabe si-compare u-2 no-4 singayikhansela ngoba phela le volume abathi asikhulume ngayo ka-hydrochloric acid, kodwa lo hydrochloric acid ongesilo i-gas, because phela ukuze u-affectwe i-pressure lecashe ngapha kwale volume you must be a gas. Inkinga phela manje lo hydrochloric acid akasilo i-gas, so asikwazi ukuthi singakhuluma ngani nge-pressure yakhe ngoba phela akasilo i-gas. Which means siyayikhipha nje le column exactly, asizukhopera lutho lapha le column le ka-volume of hydrochloric acid between experiment 2 and 4. Then when you look at the state of division, siyafana granules, uyabona? Granules la, siyafana, granules. When you look at temperature iyafana 25. Uyabona ukuthi nje manje since sengiyikhiphile le column le, since sengiyikhiphile le column le volume, lama column asesele yonke into esikhona iyafana, concentration is the same, state of division is the same, temperature is the same, which means the time of reaction nayo futhi will be the same phela, because i-pressure phela ayenzanga mehluko. Akukwazi ukuthi mina khona ukuthi mina ngingathi there's a difference between abantu where there was nothing that was changed. Uyabona? Angikwazi ukuthi khona umehluko wenzekile futhi kungabanga i-effect, because lo muntu lo oyi-pressure, the pressure of hydrochloric acid ngeke zibe na effect kulama-experiment ngoba phela u-hydrochloric acid akasili gas. Which means the value of X laphana will be 14 ngoba phela yonke into experiment 2 and 4 iyafana. Into esihlukile nje ile pressure le laphana le ecashiswe ngevolume, and le pressure ayimthini phela hydrochloric acid, which means noma singalikhansela lela column. So the value of X is what? Is 14. So now the Maxwell-Boltzmann energy distribution curves. So uMaxwell-Boltzmann ngikhulumile ngama-graph wakhe izolo, ngikhulumile ngama-graph akhe, or on my last video ngikhulumile ngama-graph akhe awu 3 ama-graph akhe, concentration, temperature, addition of a catalyst. So in this case bakutshela ukuthi bakunikeza ama-graph ka-Maxwell-Boltzmann distribution curve for particles, bathi curves. Ngoba bethi curves kusho ukuthi abazokhuluma nge-curve eyodwa, kungenzeka ukuthi bawafake u3 ama-curves kule graph le, noma bafaka u2, kodwa ayizukuba yodwa i-curve abakhuluma ngabo, because they said curves, baze bafaka u-S la bathi curves. Yabona le nto le? Yes. So bathi for particle in each of the experiments in 135 as shown, which means kulama curve esiwanikezwe la kuno-experiment 1, kuno-experiment 3, kuno-experiment 5. Kodwa sizothola kanjani ukuthi yena kumuphi yena u1, yena kumuphi yena u3, yena kumuphi yena u5? Ngicela sibuke lo ma-experiment specifically. Ngicela sibuke u1. Okay, u1 siyambona une-concentration u2, i-volume yakhe u200, upowder, i-state of division upowder, i-temperature u25. Okay, but i-state of division noma singasibhekanga ne-volume futhi noma singakubhekanga, because awekho ama-graph athinta i-pressure, awekho ukuthi ama-graph athinta i-surface area. kodwa noma singabheka abantu nje kumele siwabheka la in this case kuzomele sibheke i-temperature ne-concentration because ibona abanama-graph ka-Maxwell-Boltzmann distribution curve. Kuzomele sibheke nje labantu labo bobabili labo. So i-concentration iwu-2, i-temperature iwu-25. Okay, ku-experiment 3 i-concentration iwu-5. Uyabona ukuthi the concentration was increased from experiment 1 to experiment 3. I-concentration increasiwe nje masiswa ku-experiment 1 sake experiment 3, and le concentration experiment 1 iyafana ne-experiment 5, which means umuntu uthini isilindele ukuthi ebe ne-concentration enkulu u-experiment 3 ngoba uyena one-concentration whereby the concentration was increased, uyena ne-concentration e-increasiwe. So uyena kumele simbheke nje emagraphini because ngichazile lento kule video siphuma kuyo ukuthi uyibona kanjani i-increase in concentration. Then i-temperature yakhe ibe-25. Okay, afana ama-temperature ka-1 no-3. Then size ke-experiment 5 i-concentration ka-5 iyafana neka-1 okuyi-concentration encane kunekabani kuneka-3. Then i-temperature iyu-35. So the temperature on experiment 5 was increased. Yabona? So sizoyibheka futhi ne-increase in temperature because ukhumbule ukuthi ngikhulumile ngalento ukuthi when you increase temperature, more particles will have sufficient kinetic energy, and ama particles that have sufficient kinetic energy so abona on the right of what? Of activation energy. Ukhumbule. Then now let's look here. Now we experiment A, graph of A, noma curve A, curve A. But mabu curve A uyi-graph ye-concentration. Uma curve B nayo futhi uyi-graph ye-concentration. Kodwa u-curve B mkhulu kune-graph kuno-curve A. Wena kumuphi umuntu one-concentration enkulu compared to kwamanye ama-experiment lawo siwabhekayo, because kumele kube khona lo muntu one-concentration enkulu compared to kulamanye siwabhekayo. Umuphi lo muntu? U-experiment 3 uyena one-concentration enkulu compared to u-1 no-5, which means u-B wethu u-1 u-experiment 3. Then masibuka the graph of A, i-graph of A into esiyibonayo ngayo nje it has just less concentration compared to u-B. Ake sibuka u-C. Uma ubuka u-C, more particles have sufficient kinetic energy because lento siyishilo sathi laba bangapha ngako right ku-activation energy, this is activation energy, this is activation energy. Laba bangapha ngako right ku-activation energy bane sufficient kinetic energy. Yabona? But laba bangapha ngaka left they do not have sufficient kinetic energy. Lento ngikhulume ngayo kakhulu izolo or on my last video, ungahamba uyicheka khona ukuthi ngikusho kanjani lo. So mawuthi ambheka u-C, C has more on C rather there are more particles with sufficient kinetic energy. So when there are more particles with sufficient kinetic energy, sisho ukuthi temperature is increased. Because when more particles have sufficient kinetic energy, temperature is what? Is increased. And in temperature increase experiment ba experiment 5 na isi 35 laba into beno 25 but experiment 5 waba no banini waba no 35. So automatically sesiyazi ukuthi lo experiment 3 sesiyazi lo ukuthi experiment 5 but lona sesiyazi ukuthi uba experiment 1. To identify graph A, B and C that represent the following. Experiment 3 sesiyamazi experiment 3 which would be give a reason for your answer. It's because curve B have a high concentration compared to A and C. That is the reason. To experiment 5, to give a reason for us. About experiment 5. Experiment 5 oh C. Why is to C? Because more particles have sufficient kinetic energy on C compared to A and B. Yabona ukuthi ama particles ane sufficient kinetic energy ka B angakanani. Na ka A la izansi ka B ukuthi mancane angakanani. But ka C maningi ane sufficient kinetic energy. So now, experiment 6 is now conducted using a catalyst. Indaba ye-catalyst mfethu ngichazile izolo ukuthi ngichazile in some more detail on my last video. Ngicela ukuthi uma ukuthi awukazi uyibuke la video ngicela ukuthi ubuyele kuyo before uzobona le question because yonke into engizokhuluma will be based on what I did. So experiment 6 is now conducted using a catalyst and the same reaction conditions as for experiment 1. To experiment 6 ke manje siyamenza simfaka i-catalyst kodwa ama-condition wakhe asafana naka experiment 1. Baqonda ukuthini labantu? Baqonda ukuthi yonke into ela ku-experiment 1 iyafana nento ezoba ku-experiment 6. Yonke into. Besides-ke i-reaction time, and ngizokutshela ukuthi indaba ngithi ngaphandle kwe-reaction time, kodwa yonke into from here izoba khona ku-experiment 6, yabona, because basho bathi ama-condition azofana ku-1 no-6, just that ku-6 kuzobe sekungenani ne-catalyst. Into ezohlukisa-ke isikhathi ukuthi phela u-6 since yena sene-catalyst kusho ukuthi the reaction will happen faster, because umsebenzi we-catalyst, it is used to speed up the reaction. Yona it is not part of the reaction, but it is used to does what? To speed up the reaction, which means u-6 uzothatha isikhathi esincane ukuthi enzeke compared to 1. Even though ama-condition wabo efana, yonke i-concentration, yonke i-volume, sonke state of division kufana konke, kodwa-ke u-6 uzokwenzeka faster than u-1, noma u-6 uzothatha isikhathi esincane ukuthi enzeke ngoba phela yena une-catalyst, umuntu ozomsheshisa, uyabona. Catalyst liyangena ku-6, i-catalyst liyamngena u-6, lithi i-catalyst mabe liqeda kumngena u-6 lizomenzani, lizomenza faster, uyabona, because u-1 ubenziwa just slowly, ubenzeka slowly due to ama-condition ade nawo, uyabona. Even though ama-condition efana, but lo since sine-catalyst uzokwenza njani, uzokwenzeka faster. Therefore the reaction time will differ, and the reaction time ka-experiment 6 izothanda ukuthi mayibe incane ne-reaction time kabani ka-experiment 1. So what is the function of a catalyst in this experiment? Sengishilo. Function of a catalyst in this experiment, it is used to speed up the reaction, but it is not part of the reaction, or it is used to increase the rate of the reaction, but without itself undergoing a permanent change. It is just used to increase the rate of the reaction. Increase the rate of reaction, there will be no permanent change that will be done on a catalyst. Ama-catalyst, when you come to a higher stage, uzobona catalyst we have homogeneous catalyst and heterogeneous catalyst. Uma bese khuluma nge-homogeneous catalyst, leli catalyst leli elifanayo nama-reagent wakho noma nama-reactants wakho. Yabona, since lapha ngireaktisa uzinc no-hydrochloric acid, esinye lapha uzinc no-hydrochloric acid bafana no-water no-methanol, mhlambe bayinto eyodwa, yabona, ba-colorless. Mama ngizofaka i-catalyst, ngivele ngizofaka ukuthi i-catalyst el-colorless, i-catalyst ongeke uze ukwazi ukuthi uli-recycle back from u-methanol nobani no-water, yabona. That is a homogeneous catalyst. But heterogeneous ile ngikwazi ukuthi okay, njengamanje sengiyenzile i-reaction between these reagents, yama sengiyakwazi ukuthi i-catalyst ngihambe ngiyoyicaphuna futhi ngiyikhiphe, njenge-teaspoon leli ngisuke ngilifake ebhodweni labhontshisi, ngiyakhona ukuthi ngilikhiphe, yabona. Lelo teaspoon leli acts as a heterogeneous catalyst, because ngiyakwazi ukuthi ngihambe ngifike ngilikhiphe after reaction is done. How will the heat reaction in experiment 6 compare to that in experiment 1? Choose greater than, equal to, or less than. Bakubuza nge-heat ka-experiment 6 ukuthi izoba njani compared to le elaphana ku-experiment 1. Ngibethi ngicela ukubuza, ngicela nje ukuyibuzela. Nayi lento le. Nayi lento le. Nayi lento le. Unamabhoda awu-2. Unamabhoda awu-2, unamabhoda awu-2. Leli ulofaka u-teaspoon, uzopheka ubhontshisi. Leli alinalo i-teaspoon. Just uyabasa nje lana. Uyabasa nje just. Naleli alinalo i-teaspoon, uyabasa just leli. Uyabasa. Oh, linalo leli teaspoon, uyabasa just, uyabona? Uyabasa nje. Okay. Ngisacela ukubuza mfethu. Uma ngabe lo mlilo, angithi uyazi ukuthi umlilo uma ngabe uvutha ebhodweni uhlezi uqhamuka sideways, which means whatever is inside this system izo-experience i-heat eqhamuka from either sides, uyabona. Izo-experience i-heat eqhamuka ngaka left ne-heat eqhamuka right, which means i-heat yona izoyidonsa kuphela uma ngabe i-heat izoqhamuka kanje. But in this case, whatever is inside this system izokwazi ukuthi i-experience ne-heat ezoqhamuka direct, because umsebenzi walela catalyst lizoyidonsa i-heat ukuthi i-heat ayidonseke futhi direct, noma ethi ukuthi isazoqhubeka idonseke sideways, kodwa isizokwenza njani manje, isizodonseka direct, uyabona lento leyo. So uma ngabe i-heat ngiyidonsa direct, uyabona ukuthi i-heat iba ningi kakhulu in this reaction where there is a catalyst. I-heat iba ningi kakhulu in this system compared to that, because laba mdonsa ngama-side i-heat, but lo uyidonsa even direct, yabona. Yes, so into enzakalayo lo muntu one-catalyst uzoba ne-heat eningi kunalo muntu lo ongenayo i-catalyst. So lo muntu one-catalyst, since experiment 6 efakwe i-catalyst, so which means experiment 6 uzodonsa i-heat eningi kune-experiment 1, which means the answer here is greater than. To calculate the average rate of reaction in mole per minute, bazokutshela i-average rate of reaction bayifuna ukuthi kanjani. So with respect to zinc for experiment 2, if 1.5 gram of zinc is used ku experiment 2, experiment 2 now experiment 2 here, i-reaction time yakhona ibani ibiyade ubani 14, bathi la experiment 2 basebenzise ubani u-1.5 gram zinc that was used, bafuna ini i-reaction i-average rate rather. Okay, akasambe soyicalculate i-average rate. I-average rate is the same as the reaction rate, just the one thing, yabona. So average rate ngizoyibhala as reaction rate, reaction rate in this case bathi bayifuna in mole per minute, which means i-reaction rate yami izoba delta n, because ama number of moles iwona azonginikeza ama units wama mole per minute, which means I have delta T here. Then now sengizodecide ukuthi kuleli formula lami ngabe ngizofaka u-minus noma u-plus. Khumbula on my last video ngithe uma ngabe kukhona u-minus, that means I'm calculating the reaction rate of the what, of the reactant. Kodwa uma ngabe kukhona u-plus, that means I'm calculating the reaction rate of the what, of the product. So ake siyobheka ukuthi uzinc yena ngabe uyini kwi-reaction yethu. Uma ngabe sibuka la uzinc uyi-reactant. So since uzinc eyi-reactant, uzinc uyini uyi-reactant, reactant. So since uzinc wethu eyi-reactant, that actually means ukuthi i-reaction rate kazinc uma ngabe siyi-calculate sizofaka ubani u-minus, because i-reactant liqala likhona mase liyadliwa. Umuntu odliwe-ke simfaka u-minus, but umuntu ogenile simfaka ini u-plus. Yabona kube leyo nto leyo. Then now let's move here, which means here we have a minus. Lo minus lo athi ngimfake ngilokhu uzobona ukuthi bekungamelanga abe khona la ngomthetho. This is delta. Bekungamelanga abe khona kodwa sisimfaka ngoba phela sicalculate ini i-reaction rate yomuntu onjani, yomuntu oyi reactant. Yes. Then now we have to get the number of moles, but before we get there asiqale sibhala i-formula lethu, because thina siyazi ukuthi into ethi mayithi change ithi final minus initial. So this is n final minus n initial divided by time final minus time initial. Yes. So let's get the number of moles, but we are given the mass ka zinc ukuthi bekade ubani, bekade 1.5 gram. Let's get the number of moles using this mass. Eating formula, number of moles is equal to mass all over what? All over molar mass. Yes. Then now mass to iubani, our mass is 1.5 divided by our molar mass. The molar mass for zinc, I think it's 65. But I think double check the periodic table. The molar mass of zinc it is 65. It's 65. And the answer is totally number of moles totally they are 0.02 mole. These are the number of moles of what? Of zinc Zn. These are the number of moles of zinc. Okay. Let's go back to our formula. Put a minus. Ngizokutshela ngala number of moles final. Lama number of moles final azoba u0. The reason why ebe u0 is because uzinc uqale ekhona wase wadliwa. That's why ngoba phela uma ngabe uyi-limiting reagent, ngichaza indaba ye-limiting reagent ukuthi wena odetermine ukuthi sizokhipha i-product engakanani. Uyidetermine to an extent whereby wena ugcina usuphela ungabisababikho, uyabona. So uma ungasekho wena it is whereby i-product nalo sizoyeka ukuthi senze njani, siproduce, sizoyeka ukuthi lizophela kahle kahle lingabe sisaproduceka, uyabona lento leyo. So the reason why sithi ama-number of moles of zinc they are 0 now because zinc is used up. Our limiting reagent of which is zinc is now used up. Usephelile uzinc. Uzinc usencibikalile kwi-acid hydrochloric acid waze waphela. Asangabe sisambona uzinc eyisolid, yabona, noma eyinto ethi mayibe yisolid. Usevele wancibikala waze waphela uzinc, yabona. Yes. Then ama-number of moles of zinc initially besisasenaye-ke la uzinc ebekade u-0.02. 0.02 divided by time final, isikhathi final lesi isikhathi esithathwe i-reaction ukuthi yenzeke sibe u-14 minus time initial was 0, then answer yakho la izoba ubani-ke calculate. This is negative of 0 minus 0.02 divided by 14. 0.0 0.00142 0.00142 or 143. Let's just put 142. This is in mole because on our numerator we have number of moles divided by what? Minute. Mole per minute. You know, answer to be funny. Then let's go back to the question. So our question here, buka sengathi iyaphela laphana ngoba la question 6 sizoqala ini chemical equilibrium okuyiyona esingafiki kuyo. So this is the end of the video. Bengithe ngizokuxoxela ukuthi yindaba yini enzakelile before ngiqala ukwenza le question. So into enzakalile la bese ngirecordile le question bese ngiyiphendulile, then kwase kwaba ukuthi bengingabonanga ukuthi ngiyenza as a recording not just as a video. So bekuzoba into bekade ungayilalela ibe yi-recording ingabe i-video ungayiboni lento engiyenzayo. So kwangiphoqa ukuthi ngiphinde futhi ngiqale phansi. Okay, so phinde sihlangane kwenye i-question sesizokwenza question 2019 but based on reaction rates. Yebo.